Hey guys and gals, we're working on finishing up our homework. In the last video, we're on 1-4 homework. In our last video, we worked on naming the following compounds. So in this video, we're going to work on just the opposite. We're going to write formulas for the compounds. So at this point, we really need our periodic table. Hopefully it's got charges and so on written on it, because that's what we're going to do for the most part. We're going to write charges, crisscross, and reduce. All right, so let's just jump right in with letter K here. We've got cesium bromide. We see that there are no prefixes in here, so we know that this one has got to be either type 1 or type 2. We see no Roman numerals, so we know immediately that it's a type 1 ionic, which means we crisscross the charges, only the numbers, not the signs, and then we reduce if possible. So let's check this out. This is going to be pretty simple. We've got cesium. We're going to change that to its chemical formula, which is Cs. We've got bromide, which comes from the element bromine, right? It just means it's in a compound with the IDE on it. And we write our charges on there. Cesium is +1 because it's in group 1. We've got bromine with -1 because it's in group 17, and that's what should be written above group 17. Our next step then is to crisscross and reduce if possible. So we're going to take this 1 down there and this 1 down there. Remember, we only take the numbers. We do not take the signs. So we've got CS1, BR1. Notice how we did not take the negative or the positive sign. We just crisscrossed the numbers. And that's because mathematically we're trying to get the charges to balance out, but we didn't really talk about that much in class. So let's just look at it this way. And so we've got CSBR. Remember, the ones are understood. We can write them if we want, or we don't have to. Awesome. Let's move on to the next one. Barium phosphate. Notice no Roman numerals, no prefixes, so we know that this one's also type 1. So all we have to do is write the names of the elements and crisscross and reduce. So we've got barium, which is Ba. It is +2, it's in group 2. Then we look at phosphate. Phosphate, it ends in ATE, which should tell us that perhaps it's a polyatomic ion. As soon as we see that ending ATE, we should know that it is a polyatomic ion. So we look up at the top of our periodic table and we see another table, and that's our polyatomic ion table, and we see phosphate in there, and phosphate is PO4 and its charge, this whole thing, is -3. Everything is -3. So now we're ready to do our crisscross. Remember, just take the numbers 3 down, 2 down, and so we'll write that over here. We've got BA3. That came from that 3 there. And then we've got parentheses PO4, parentheses 2. The reason we put the parentheses in is because we don't want it to look like we have 42 O's, because that would be incorrect. All right, so our ending formula should be BA3, parentheses PO4, parentheses 2. All right, let's move on to the next one. The next one, we have ammonium chloride. And ammonium sounds kind of like an element, but it's actually not. It's a polyatomic ion, and it's found at the top of the page in that polyatomic ion table. And so there we get ammonium is NH4, and it is +1. All right. Chloride is from the element Cl, right? And it's -1. So if we crisscross, we're going to get a 1 down there and a 1 down there, which means NH4, 1, Cl, 1. So we can reduce out those ones or remove the ones, which gives us NH4, Cl. A lot of you have been putting parentheses in, just like that, maybe without the 1. That is not incorrect, but typically parentheses are only if you have more than one polyatomic ion. But if you keep doing that, it will not be wrong. It will not be counted wrong. Okay, let's move on to the next one. We've got sulfur hexafluoride. As soon as we see the prefix hexa, we should know that this is a covalent compound, and that way we don't have to look up any charges. All we have to do is write down what it says. So sulfur is S. Since there is no prefix on it, that means that sulfur is 1. Hexafluoride, fluoride is F. Hex means 6, so our formula is officially SF6. Alright, simple enough. Alright, let's move to a type 2 ionic. We know it's type 2 because of that Roman numeral right there. But this makes it very easy for us. What we've got is we've got copper, which is Cu. I'm going to put that part over here, Cu, and it's +1. Remember, in that last video, we just learned that that Roman numeral is the charge on our cation. So we don't essentially have to look it up. Then we've got sulfide, which comes from the element sulfur, and it's -2. So we do have to do our crisscross. So we're going to put the 2 down here, the 1 down there, and we're going to get Cu2S1. And again, like always, we can reduce out that 1 if we want, so it's just Cu2S. Alright? Awesome. Moving on to P, we've got lead-2 oxide. Lead-2 tells us that it's type 2 ionic, and then that just, again, makes it really easy for us. Lead is Pb. This 2 means that lead is +2. Alright? Oxide is O, it's -2. So again, we're ready to do our crisscross. 2 down, 2 down. We're going to get Pb2O2. But the last step in crisscross is crisscross and reduce if possible. Well, we can take a 2 out of all of these, so we're going to just say PbO. That is our formula for lead-2 oxide. Awesome. Let's move on to carbon tetrachloride. Carbon tetrachloride, again, we see our prefix tetra, so that should tell us we have covalent. So all we have to do is write down what it says. Carbon, C. Since there's no prefix on it, we know carbon is 1. Tetrachloride. Chloride is Cl. We know that tetra means 4, so our formula is CCl4. Carbon tetrachloride. All right, on to R. We have sodium hydroxide. There's no prefixes, no Roman numerals, so that tells us right away it's it's type 1. So we just write what we've got. Sodium is Na, it's +1. Hydroxide is kind of one of those tricky ones. There's not an official element called hydroxyum or whatever. All right, hydroxide is actually a polyatomic ion, so we've got to look up top. And hydroxide is -1. That whole thing is -1. So we can crisscross and reduce if possible. 1, 1, which gives us Na1, parentheses, OH, 1. Or we could just write NaOH because we saw that the 1s would cancel out and we'd be set. Okay. And 2 left. We've got aluminum bromide. Aluminum bromide, there's no Roman numerals, no prefixes, so we know it's type 1. So we're going to write aluminum. We have to look for aluminum's charge. It's in group 13, so aluminum is +3. We've got bromine, which is Br, and it's -1. So if we do our crisscross, 3 down there, 1 down there, so that is Al1Br3, which gives us Al-Br3. Awesome. And would you look at that? I made a mistake on this last one. ICl3 should be over there. But if we were to name this, this would be iodine. Trichloride. There'll probably be a different one when you actually get the assignment, but hopefully we're good. All right, thanks. See you next time.